Hydrogen can be prepared in an industry by electrolysis of acidified water or dilute tetrodosulfate 6-acid. However, it can also be prepared in large quantity in the industry using cheap raw materials like water and coke. Although this involves two steps, the first step resulting to the production of water gas, while the last step results to reduction of water to hydrogen. Recall that water gas is a mixture of carbon dioxide and hydrogen, and it is produced using steam and coke. In fact, steam is passed over red hot coke. That means at a very high temperature. Steam oxidizes carbon to carbon dioxide and hydrogen gas, which is water gas. Now this water gas mixed with more steam to produce carbon dioxide and hydrogen. The carbon dioxide is removed by passing it over certain compounds like caustic soda solution. This means that carbon dioxide and unreacted carbon dioxide are removed using caustic soda solution and chemical solution. Take a look at the fact that the two reactors involved are endothermic reaction and exothermic reaction. The first stage, when steam is passed over a body to produce water gas, is an endothermic reaction, while the last stage of the reaction, where water gas mixes with steam to produce carbon dioxide and hydrogen, is an isotonic reaction which gives out heat to the surroundings. However, this method is replaced by a similar process which uses cheap hydrocarbons like methane instead of coke. The reaction also involves two stages. The first stage, where methane reacts with steam to produce synthesis gas, which is CO plus H2. And the second stage, where synthesis gas reacts with more steam to produce carbon dioxide. The carbon dioxide is still removed in similar manner as in the reaction involving water gas. Now, how do we confirm that the gas produced is actually hydrogen? This is done by using lighting with spirit. Put unknown gas into the system. Bring the lighting spirit closer to it. If the gas makes a pop sound with the lighted spirit, then the gas is hydrogen gas, because hydrogen makes pop sound when it comes in contact with air, in bracket oxygen. The lighted spirit indicates that there is presence of oxygen, and you have this oxygen in there. So when it mixes with hydrogen, it makes a pop sound. Small quantity of hydrogen should be used for this test, as large quantity is explosive. temporary and easily reversible or permanent and very difficult to reverse. These changes, be it physical changes or chemical changes, are as a result of the physical properties and chemical properties of hydrogen. Now let's look at the physical properties of hydrogen. Hydrogen is a gas and liquid. It is colorless, odorless, and tasteless. It is neutral to moisture transport, indicating that it has no effect on which litmus paper, be it blue litmus paper or red litmus paper. Hydrogen has a melting point of minus 259 degrees Celsius and boiling point of minus 253 degrees Celsius. It is relatively insoluble in water and less dense than air. In fact, it is 14.4 times less dense than air. Now let's look at the chemical properties of hydrogen. It's actually two. One is the reducing property of hydrogen. As a reducing agent, it has a strong ability to reduce other substances. It also involves combination reaction. Taking each of the reactions one at a time, let's consider the reducing property. Hydrogen reacts with metallic oxides, produce water and metal oxide. Oxide to copper metal, like the image. The metallic ore is reduced by hydrogen gas, leaving behind copper. It can also reduce lead oxide, zinc oxide, nitric oxide, and a few others, producing the metal. Hydrogen have several compounds, but there are also strong compounds of hydrogen that are powerful reducing agents. Examples of these compounds are lithium tetrahydridyl aluminate 3, which has a formula of NiAlH4, and sodium tetrahydridyl borate 3, has a formula of Na8,4. These compounds are very strong reducing agents that are compounds of hydrogen. Considering the combination reaction, it's nice to refresh your memory on what you mean by combination reaction. It is actually a reaction between two or more substances combining to form several combination reactions of hydrogen. Now let's start with reaction with some reactive metals like sodium, potassium, and calcium. Hydrogen reacts with metals to form metallic hydrides. From this slide, sodium reacts with hydrogen to form sodium hydride. The sodium hydride is an ionic compound. It means that the hydrogen here accepts electron to form a negative ion, while the sodium gives out electron to form sodium ion. The oxidation number of hydrogen here is -1 and not the usual +1. However, this hydride, when they dissolve in water, they also release hydrogen gas. Hydrogen also combines with halogens. What do you still remember about halogens? I'm sure you remember they are the 7 elements in which includes fluorine, chlorine, bromine, iodine. So when hydrogen reacts it forms what we call halides, precisely hydrogen halides. A halide is a compound of 7 elements that is made up of 2 elements, out of which 2 elements, one is a halide is a binary compound of 7 elements. When we say hydrogen halide, it means that the second element is hydrogen. An example here, chlorine combines with hydrogen gas to produce hydrogen chloride gas. Actually, when this gas dissolve in water, they form acids. Similarly, bromine also combines with hydrogen to form HBr, still in the gaseous state, while iodine combines with hydrogen to form HI, still in the gaseous state. Each of them, when they dissolve in water, they form acid. Another combination reaction is reaction with oxygen. Pure hydrogen burns in oxygen with a pale blue flame to produce steam. Remember, we made similar reaction when we talked about tests for hydrogen. But in such case, it was the air that is used. Of course, you know, the component of air that is combustible is oxygen. However, it's not pure. Pure hydrogen burns in oxygen, burns with a pale blue flame, producing steam. And the equation is H2 plus O2 to give you H2 steam. The equation is balanced. The law of conservation is certain that atoms are neither rather change from one form. As I said before, make sure the hydrogen mixes with air. That was why during test, I remember mentioning the fact that small quantity of hydrogen will be used, as when large quantity is used, the explosion will be very dangerous. Please do watch the second video for several uses of